All right, let's just dive right into this. Welcome to today's explainer. Today we're looking up at the night sky to untangle one of the most fascinating and honestly kind of confusingly named celestial events you can spot from your very own backyard. We're talking about lunar radiance, and specifically, we're zeroing in on the first quarter phase of the moon. If you've ever gazed up and wondered about the exact mechanics behind what you're actually seeing up there, well, you are definitely in the right place. We're going to break down the geometry, the best viewing times, and this really brilliant technicality at the end that honestly might just blow your mind. So, let's kick things off right out of the gate with a question that causes a bit of cognitive dissonance for anyone paying attention. Why exactly does a quarter moon look exactly like a half moon? It's one of those things we all learn in grade school and just kind of accept, right? We never really stop to think about how weird it is. I mean, think about it. If you order a quarter of a pizza, you're expecting a slice, not half the whole pie. And yet, when astronomers tell us to go look for the first quarter moon, our eyes are clearly seeing this giant glowing half circle hanging up there in the sky. And this paradox right here is exactly what we're going to solve today. On one side of the coin, you have the official astronomical name, first quarter. But on the flip side, you have its actual physical appearance from our vantage point down here on Earth, which is a 50% illuminated half circle. It's this really striking linguistic irony. The name is literally telling us 25%, but our eyes are screaming 50%. So to understand why this happens, we need to completely shift our perspective. We have to stop thinking about what the moon looks like and start thinking about what the moon is actually doing out there in space. Which brings us to Section 1, Orbital Geometry Explained. Okay, let's zoom out from the Earth's surface for a second and look at the celestial mechanics at play here. Everything kicks off with the new moon. Now, during a new moon, the moon is positioned right between the Earth and the sun, which means the side facing us is totally bathed in shadow. We can't see it at all. But, the moon doesn't just sit there, it's constantly on the move. Fast forward approximately 1 week later, and it reaches the first quarter phase. So we're really tracking a chronological journey here. The first quarter isn't just some static shape in the sky, it's actually a very specific milestone on a week-long journey through space that kicks off in total darkness. Now, the real key to our whole quarter versus half puzzle lies right here with that 25% chunk. The term first quarter has absolutely nothing to do with the percentage of the moon's surface that's lit up, not at all. Instead, it's all about time and distance. The moon has completed exactly 1/4, or 25%, of its orbit around the Earth relative to the sun. So the next time you hear someone say first quarter, I want you to think of it more like a lap marker on a racetrack, rather than a description of the moon's actual visual shape. Which brings us to a super important number, 90. Because the moon has traveled exactly 1/4 of the way around its circular orbit, it's created this perfect 90-degree angle relative to both the Earth and the sun. Just imagine drawing a straight line from the sun to the Earth and then another line from the Earth up to the moon. At the first quarter phase, those lines form a perfect 90-degree right angle. And it's because of this exact spatial positioning that sunlight is hitting the moon right from the side, at least from our perspective. And boom, that is exactly why we see precisely half of the illuminated portion. The geometry perfectly dictates the visual. All right, moving on to Section 2, a lunar viewer's guide. So now that we've got the orbital mechanics locked down, let's talk about how you can actually step outside and experience this for yourself. The absolute most crucial point here is knowing when and where to look. Turns out, the first quarter moon runs on a very specific daily schedule. It actually rises right around noon. And because it's rising so early in the day, it's highly visible in the afternoon sky while the sun is literally still out, and then it carries over just beautifully into the evening. After that, it sets right around midnight. Oh, and if you happen to be observing from the northern hemisphere, you'll be able to easily spot it because it's the right half of the moon that appears brightly lit up. Now, if you do decide to grab a telescope or even just a decent pair of binoculars, you are definitely going to want to focus on one specific feature, the Terminator. And no, I'm not talking about the action movie. In astronomy, the terminator is the line that divides the illuminated and dark portions of the moon. And why does this matter? Well, because looking right along that dividing line provides absolutely spectacular opportunities for observation. The low angle of the sunlight hitting the terminator casts these incredibly long shadows, which makes craters, mountains, and all sorts of other lunar features stand out in incredible, stark relief. It's honestly breathtaking. Let's get into Section 3, the dichotomy technicality. Okay, so just when you think you have this whole thing figured out, astronomy throws a massive curveball at us. Get this. At the exact moment of the first quarter, slightly more than half of the moon is actually lit. I know. We literally just spent all this time explaining why that perfect 90-degree angle gives us a flawless 50% half circle. But scientifically speaking, at the precise mathematical moment the moon hits that orbital first quarter milestone, the illuminated portion we see is actually a tiny, tiny fraction over 50%. It is not a perfect half. Crazy, right? So, if we want to find that true perfect 50-50 split, we have to look at this concept here, dichotomy. Dichotomy is the exact moment when precisely half of the moon is illuminated. But here is the fascinating twist from our source material today. The moment of dichotomy actually happens a few minutes before the first quarter phase even occurs. Basically, the visual half moon and the orbital quarter moon are technically separated by a few minutes of time. The universe really is in the details. Which honestly leaves us with this final thought to wrap up today's explainer. Think about it. If a quarter moon is actually a half, and the true 50% visual half illumination happens minutes before the actual official orbital phase is even reached, can we ever truly trust our own eyes when we're looking up at the night sky? It just goes to show that while the cosmos is beautifully predictable, the terminology and those precise mathematical mechanics are always hiding an extra layer of wonder, just waiting for us to look a little bit closer. Keep looking up, and always keep questioning what you see.